Step Talks Education. Let us continue with our qualitative analysis, ionic chemistry and qualitative analysis, and we are going to the detection of cations as our first ions. Remember, we had a general look at how to detect cations using sodium hydroxide solution and ammonia solution. So now we are going to look at these cations one by one and how they respond in this case to the reagents of sodium hydroxide and ammonia solution. So in this case, let us start with the use of sodium hydroxide solution as our major reagent. Sodium hydroxide solution is a major reagent in this case, used for detecting the cations that we have seen in this case. And we are looking at detecting the cations when they're in solution. So this one is a solution of a reagent, and then the solution under test, which we have already prepared, contains the free ions, which responds very easily to the solution of the reagents, as we have already seen, adding dropwise until in excess. So let me write the test instruction here. To a solution under test, add sodium hydroxide solution dropwise until in excess. Add sodium hydroxide solution dropwise until in excess, and then specifically for ammonium ion, the instruction will go ahead and say that you go ahead and you heat the mixture. So let me just add it here that if no precipitate forms, then heat the mixture. And we say that when you heat the mixture, we shall be targeting ammonia gas, and we should be ready to test for ammonia gas. So in this case, let us look at a table for this. In this case, we shall have a table for observations and then the deductions that we are going to make from this test here in particular. So I will have observation and then the deduction. Observation and then deduction. So I may have, if I've got a white precipitate insoluble in excess. A white precipitate insoluble in excess. That means I added the reagent dropwise, some few drops, I got a white precipitate, then I added in excess, it refused or it failed to dissolve. Not that it refused, but it failed to dissolve. Then this is a characteristic observation of calcium ion, and then we have also magnesium ion. Only these two cations. We may not be so much bothered with it. Other writings is present or is suspected, probably present, suspect, something of those kinds. Just write for us the cations. These are the cations that gives us this observation. Since there are two, we have not yet zeroed on the very one which is present, because both of them gives us the same observation in this case. So let us not forget this one here. If you have got a white precipitate insoluble in excess, then it is calcium ion or magnesium ion that's likely to be present. We may also get a white precipitate soluble in excess to form a colorless solution. If we have this observation of a white precipitate soluble in excess to form a colorless solution, then I have these friends here, these cations, that is zinc ion, aluminium ion, and there is also lead-2 ion. So these three cations give us the same observation of a white precipitate soluble in excess to form a colorless solution. I said that if it dissolves, if it is soluble, then be ready immediately to accompany it with the color of the solution formed, or the resultant solution. So these three, zinc ion, aluminium ion, and lead-2 ion, some people call them ZAP, the ZAP cations. They all give us the same observation. So we write all of them, do not omit any. All of them gives us the same observation with sodium hydroxide solution. Now let us proceed to another observation. If we have got no observable change. So where are we? We are here. If no observable change, that means if no precipitate forms, no observable change, no precipitate forms, then you need to heat the mixture, and that's what the instruction will say, that to the solution you add sodium hydroxide solution dropwise until in excess, and you heat the mixture. So no observable change, this is one of our observations. Then on heating, we have a colorless gas with a choking, irritating smell, and which turns moist red litmus paper to blue was evolved. So no observable change, no precipitate formed. Then on heating, a colorless gas with a choking, irritating smell, and which turns moist red litmus paper blue was evolved. This gas is ammonia gas. We need to identify any gas that is produced. So ammonia was evolved, and therefore we have what? Ammonium ion. And this is a confirmatory test for ammonium ion in this case. Let me put a star here to show that this one is a confirmatory test for ammonium ion. There is no any other reagent that gives us any observation with sodium hydroxide solution just like ammonium ion. So it is a confirmatory test in this case. Let us look at another observation. A blue precipitate insoluble in excess. What does blue go with? Blue goes with copper 2 ion in this case, as we saw earlier on with our preliminary test. So you can see it's trying to follow us here with the colors of the cations. A blue precipitate insoluble in excess. This one means that there is copper 2 ion. So as simple as that. That is with copper 2 ion. Copper 2 ion is strictly able to for us a blue precipitate, not a green one this time when we are using the actual test reagents. We shall not have any green precipitate having copper 2 ion. For copper 2 ion is strictly a blue precipitate. That green color is only for the preliminary observation or the preliminary test, when we have only prepared a solution or when we have been provided with the substance and it looks to be blue. But now when we use the solution, even if it was green but containing copper 2 ion, if we use sodium hydroxide solution this time, when we add it dropwise until in excess, we shall strictly get a blue precipitate which is insoluble in excess. Now, in case we have got a green precipitate insoluble in excess but turns to brown on standing. A green precipitate. Green goes with the color of ion 2 ion. So we shall say it is ion 2 ion. But then there is something here, that the green precipitate gradually turns to brown on standing. This one is simply because of the atmospheric oxidation, that is the effect of oxygen, the atmospheric oxygen on the ion 2 ion in the green precipitate. It will be converted from ion 2 ion to ion 3 ion, and then we see the color changing from green to brown. But that one should not make us think that there is ion 3 ion in the original substance. It is an effect of the atmospheric oxygen on the green precipitate, not on the original substance. So that original substance or solution consists of ion 2 ion. Only that the ion 2 ion oxidized to ion 3 ion. I'm using S because this is British English. Ion 2 ion oxidized to ion 3 ion on standing by the atmospheric oxygen. So this is with the ion 2 ion. It is not stable, such that if you leave it to stand for some time, it will change from green to brown. That is with the ion 2 ion. And that is it. That's why in most cases, salts of ion 2 ion that we want to use, we prepare them freshly and just use them, because when they remain standing for some time, then the ion 2 ion in the salt will be converted to ion 3 ion, and you see it changing from green to brown. Finally, we may also have a brown precipitate insoluble, one word, insoluble in excess. So brown is a characteristic color of ion 3 ion. So we strictly say ion 3 ion in this case, and that is the color of ion 3 ion, a brown precipitate. So these are the possible observations that we shall make. And sodium hydroxide solution is always the first reagent that we use. So let us, in this case, stop at this. In our next test, we are going to see the chemistry behind these observations here, or the reactions involved. So, Tep Talks Education, thanks for watching.